The FIGNEWS shared task, organized as part of the ArabicNLP 2024 conference collocated with ACL 2024, addresses bias and propaganda annotation in multilingual news posts. It focuses on the early days of the Israel war on Gaza as a case study, aiming to foster collaboration in developing annotation guidelines for subjective tasks by creating frameworks for analyzing diverse narratives highlighting potential bias and propaganda. The task is multilingual, encompassing 5 languages: English, French, Arabic, Hebrew, and Hindi. A total of 17 teams participated in 2 annotation subtasks: bias, 16 teams, and propaganda, 6 teams. The teams competed in 4 evaluation tracks: guidelines development, annotation quality, annotation quantity, and consistency. Collectively, the teams produced 129,800 data points. Key findings and implications for the field are discussed. The FIGNEWS shared task is a collaborative research environment focused on detecting bias and propaganda in news media. It aims to develop best practices in data annotation and analysis, ultimately improving media literacy and fostering a more informed public. This task builds upon previous research on the impact of bias and framing on political and social realities, including studies on multilingual contexts, detailed datasets for bias detection, and techniques for identifying biased language and propaganda. Framing, as defined by Entman, 2007, is the process of selecting certain aspects of perceived reality and constructing a narrative that emphasizes their connections to promote a specific interpretation. This concept highlights how news framing can influence public perception by emphasizing particular elements over others. Recent studies have developed methods and datasets to detect news bias, such as crowdsourced content analysis and computational approaches for detecting framing in political news. ArXiv et al. 2020 explored the complexities of news framing across different languages, while Heppel et al. 2023 provided a valuable dataset and linguistic insights from 2 multilingual disinformation websites. Detailed and well-annotated datasets have been recognized as crucial for bias detection. The MBIC dataset, introduced by Spinday et al. 2021a, includes annotator characteristics and provides labels for bias identification at both word and sentence levels. TASI, a text annotation survey system developed by Spinday et al. 2021b, enhances the quality control of annotation processes in NLP tasks. Techniques for annotating biased language and framing in news articles have been explored, including expert annotation and crowdsourcing. Quality control and guidelines for annotation processes in NLP tasks have also been investigated, such as ArXiv, a system designed to enhance quality control in NLP tasks. Further contributions to the detection of bias and propaganda include analyzing language in fake news and political fact-checking, as well as organizing news based on their propaganda-prone content. These studies provide foundational techniques for the identification and analysis of biased and propaganda language in news media. The SEM-Eval 2020 shared task on propaganda detection, led by Martino et al. 2020a, closely relates to the FIGNEWS task, focusing on identifying propaganda techniques in news articles. Similar studies include Al-Siraj and Lubid's 2018 sentiment analysis on detecting bias in Western media coverage of Israel-related wars and conflicts, as well as Hamid et al.'s 2023 dataset for detecting and classifying offensive language in Hebrew on social media. Research on political bias detection in social media includes Joe et al.'s 2020 identification of bias in user-generated content and Lee et al.'s 2019 survey of sentiment analysis techniques. The Perpitter corpus was developed using distant supervision with refined annotations, while Hamburg et al. 2019 advanced media bias detection through automated identification via word choice and labeling. Fan et al. 2019 analyzed factual reporting to reduce bias, emphasizing the need for objectivity. Studies that form a strong basis for understanding bias and propaganda detection in media include Bailey et al.'s 2020 examination of news media profiling using text and social media analysis, which shows how news context affects bias perception. Additionally, Olcott and Jensko, 2017, Vosagi et al., 2018, and Grinberg et al., 2019, studied fake news spread during the 2016 U.S. election, highlighting the need for reliable information. The current shared task focuses on comprehensive annotation of media narratives and framing around a specific war, building upon existing annotation frameworks to develop improved guidelines. This task aims to foster a collaborative exploration of media discourses through a multilingual, multicultural lens. For data collection and selection, the CrowdTangle platform was used to collect Facebook posts related to the Israel war on Gaza in 5 languages, resulting in 15,000 posts with the highest interactions, covering different key moments of the war. These posts were divided into 15 batches, with 200 posts per language, and machine translations into English and Arabic were provided to facilitate annotation across the multilingual corpus. The shared task in this research paper consists of 2 subtasks: bias annotation and propaganda annotation. In the bias annotation subtask, participants are required to assign one of 7 labels to each post, including unbiased, biased against Palestine, biased against Israel, and others. The propaganda annotation subtask requires classifying each post into one of 4 categories: propaganda, not propaganda, unclear, and not applicable. There are 4 evaluation tracks for each subtask. The guidelines track assesses the quality of annotation guidelines based on an 8-point checklist, including defining objectives, describing the task, and establishing categories. The guideline score is calculated as the average normalized document score and normalized IAA Kappa score. The document score ranges from 0 to 8, and the IAA Kappa score is the average of all pairwise IAA Kappas over team annotators per batch. In the IAA quality track, teams compete based on their internal IAA Kappa scores, with additional metrics including accuracy, macro F1 average, F1 bias, and F1 prop. The IAA Kappa score is calculated as the average of all pairwise Kappa scores between team annotators for each relevant IAA batch and subtask. The quantity track evaluates teams based on the number of annotated data points, with teams required to complete batches in order. The consistency track assesses teams based on the centrality of their annotation choices compared to all other teams, with centrality defined as macro F1 average. To qualify, each participating team must provide full annotation guidelines for each subtask and annotate at least 2,000 posts, including Batch 1 and Batch 2, and their designated interannotator agreement subset. The bias and propaganda subtasks attracted 23 registered teams, with 17 teams technically qualifying by submitting system description papers and providing annotations for at least 2 batches in the main and IAA tracks. The annotator demographics were diverse, comprising 85 annotators from 16 teams in the bias subtask and 51 annotators from 6 teams in the propaganda subtask. The bias subtask received a total of 88,500 data points, with 72 main sets and 237 IAA sets annotated. The top-performing teams in the bias guidelines track were NLP Collab, Eagles, and Narrative Navigators. In the bias IAA quality track, NLP Collab, Justice League, and Sina emerged as winners. The bias quantity track was led by Dragon, NLP Collab, and Sina, whose annotations accounted for 56% of all bias subtask annotations. The bias consistency track was won by the Lexicon Ladies, NLP Collab, and Narrative Navigators. Notably, within Team Interannotator Agreement, IAA, scores significantly surpassed across Team IAA, with an average absolute increase of 22.6%, Kappa, and 19.4%, macro F1 average. Furthermore, the F1 bias scores, indicating binary bias determination, showed a significant difference between within-team and across-team annotations. The results of the guidelines evaluation track are presented, showcasing the performance of various teams in the bias labeling and propaganda subtasks. The table displays the scores and rankings of each team, with NLP Collab emerging as the top-performing team in multiple tracks. The bias labeling task is characterized by a high degree of subjectivity and complexity, leading to disagreements within and across teams. The average interannotator agreement, IAA, scores are 71.3% within teams and 60.2% across teams, highlighting the challenges of achieving consensus in bias labeling. In the propaganda subtask, 51 annotators from 6 teams annotated 36 main sets and 89 IAA sets, resulting in 41,300 data points. The winners of the Propaganda Guidelines track are NLP Collab, Bias Bluff Busters, and SINA. The IAA Quality track winners are NLP Collab, SINA, and the Cyber Equity Lab, while the Quantity track winners are NLP Collab, SINA, and the Cyber Equity Lab. The Consistency track winners are NLP Collab, Bias Bluff Busters, and Sahara Pioneers and the Cyber Equity Lab. The observations highlight the significant differences in IAA scores within and across teams, with an average absolute increase of over 21.1% in Kappa and 18.9% in Macro F1 average. The F1 prop scores display a wide range of disagreements within and across teams, underscoring the complexity and subjectivity of the propaganda labeling task. Overall, the results emphasize the need for meticulous attention to detail and comprehensive training in both bias labeling and propaganda detection tasks. The analysis of label distribution patterns for bias and propaganda in the dataset reveals that unbiased is the most common label, accounting for over 40% of all data points. The second most frequent label is biased against Palestine, followed by biased against Israel, with the latter being nearly 3 times less common than the former. The biased against others label appears in approximately 6% of the cases. A language-specific examination of these labels shows a general parity across Arabic, English, French, and Hindi sources. However, Hebrew-sourced texts exhibit a notable disparity, with biased against Palestine being twice the average of other languages and biased against Israel being 1/5 the average of other languages. This discrepancy could be attributed to the news media's inherent bias during wartime or a priming bias due to knowing the source language. To address this potential issue, future studies could explore comparing results with a setting where source language information is hidden and only translations are provided. This would help mitigate the impact of language-specific biases and provide a more comprehensive understanding of propaganda and bias in the dataset. Table 5 presents the top-performing teams in the bias and propaganda detection tasks, showcasing the winners of each subtask and track. The bias label distribution, as seen in Table 6, reveals that 42.8% of the total texts are unbiased, while biased texts against Palestine and Israel account for 10.4% and 0.5%, respectively. Table 7 displays the propaganda label distribution, indicating that propaganda and non-propaganda labels are almost equally distributed, with propaganda being slightly more prevalent. Notably, Hebrew-sourced texts exhibit a distinct pattern, with propaganda labels being significantly more frequent, whereas other source languages demonstrate a more balanced distribution. This observation is consistent with previous findings. Table 8 provides Pearson correlation coefficients for all bias versus propaganda label pairs, offering insights into their relationships. Biased texts against Palestine and Israel are strongly correlated with propaganda labels, with coefficients of 74.3% and 15.2%, respectively. Unbiased texts, on the other hand, exhibit a weaker correlation with propaganda labels, with a coefficient of 78.7%. These findings suggest that biased texts are more likely to contain propaganda, while unbiased texts are less likely to do so. This analysis of bias and propaganda in multilingual news posts continues with a showcase of examples from social media platforms, including Twitter and Facebook, related to the Israel-Palestine conflict. The examples, annotated with labels such as biased, Palestine, biased, Israel, propaganda, and not propaganda, demonstrate various forms of bias and propaganda across languages, including English, Hebrew, Arabic, and French. Table 9 displays a selection of texts with their corresponding annotation distributions, highlighting the complexity of annotating subjective and sensitive topics. The correlation between bias and propaganda labels is explored using data from main batches 1 and 2. Results show a strong correlation between bias not applicable and propaganda not applicable labels, as well as a positive correlation between biased against Palestine and propaganda labels. These findings underscore the need for further study on the relationships between bias and propaganda labels, emphasizing the importance of clear guidelines, examples, and collaboration in advancing NLP research on complex opinion analysis tasks. The FIGNEWS shared task brought together 17 teams to annotate bias and propaganda in multilingual news posts, resulting in a significant dataset and insights. Future research should focus on expanding annotation efforts to include more diverse languages and topics, refining annotation guidelines, and leveraging the created data to advance NLP automatic bias and propaganda detection techniques. The authors of the research paper acknowledge several limitations in the FIGNEWS shared task design and implementation. One major concern is the subjective nature of bias and propaganda judgments, which may lead to inconsistencies among annotators and teams, impacting annotation reliability. The binary labels provided might oversimplify complex issues, failing to capture nuanced viewpoints and biases within the dataset. Another limitation is the focus on the early days of the Israel war on Gaza, which could limit the applicability of findings to other news events or broader media contexts. The corpus size is relatively small, and sampling bias cannot be ruled out. Furthermore, despite a diverse range of backgrounds among annotators, some groups were highly overrepresented, potentially skewing the overall conclusions. Ethical considerations were also addressed in the FIGNEWS shared task. Measures taken include anonymizing all posts, only including publicly available posts from verified accounts, ensuring balanced representation of various viewpoints and narratives, and requiring participants to agree to use the dataset solely for research purposes. The task is partially supported by the Qatar National Research Fund. This literature review presents a comprehensive overview of the current state of research in media bias and propaganda detection, focusing on text analysis and social media context. It cites various studies that have employed computational approaches to identify media bias, including works by Bouamor et al. 2015, Budak et al. 2016, and Fan et al. 2019. These studies utilized techniques such as framing analysis, linguistic features, and crowdsourced content analysis to quantify media bias. The authors also reference several datasets and resources developed for propaganda detection, including Perpitter, Casavantes et al. 2024, a Twitter corpus for computational propaganda detection, and Biasly, a platform providing politician ratings. Additionally, they cite works on natural language processing, NLP, in the Arab world, Darwish et al. 2021, and annotation guidelines for bias detection in news narratives, Ghislain Bourahoud and Samhaa Amer, 2024. Furthermore, the authors highlight recent studies on media bias and propaganda detection in the context of specific events, such as the 2016 U.S. presidential election, Grinberg et al. 2019, and the Gaza-Israel war, Muhammed H. S. Hellel et al. 2024. They also mention works on improving the quality control in the annotation process for NLP tasks, Jonatas Grossman et al. 2020, and identifying keywords for bias annotation guidelines, Yusra Allah El-Gawi et al. 2024. The literature review also covers various NLP approaches for media bias detection, including works by Entman, 1993, 2007, on framing bias, Hamburg et al. 2019, on automated identification of media bias, and Naghamhamid et al. 2023, on offensive language detection using BERT. Overall, this literature review provides a comprehensive overview of the current state of research in media bias and propaganda detection, highlighting the importance of text analysis and social media context in identifying and mitigating media bias. Propaganda detection, bias analysis, and fake news identification in natural language processing, NLP, are pressing concerns that have garnered significant attention from researchers in recent years. Existing research in these domains primarily employs machine learning, ML, and deep learning, DL, approaches, leveraging datasets and benchmarking methods to assess the performance of proposed models. Recent studies have extensively explored various linguistic features and methodologies to improve propaganda detection accuracy, including text representation learning and transformer-based architectures. Moreover, research in bias analysis has introduced novel metrics for evaluating and mitigating biased representations in language models. A prominent study utilizes an annotated dataset to assess the efficacy of multimodal models for detecting propaganda, focusing on language styles, source characteristics, and persuasive strategies. Other works explore multitask learning for propaganda and fake news identification, reporting improvements in classification accuracy through simultaneous optimization of shared parameters. Significant advances in explainability techniques for propaganda and fake news identification models have been achieved, offering insights into linguistic markers of deceptive and persuasive text. Transfer learning from out-of-domain tasks to specific fake news scenarios has been investigated as a promising strategy to tackle low-resource and imbalanced data problems. In analyzing benchmark datasets for fake news and propaganda, existing literature has demonstrated inconsistent model performances and noted data scarcity in representative multiclass problems. Emerging methods like generative models, language games, and robust control demonstrate promising research avenues, alongside debates around broader applications, long-term data representation implications, and fundamental considerations regarding decision transparency in current language model configurations. Assessment metrics applied across recent works differ due to variant propagandist classifications. Important observations related to interpretability frameworks, further application relevance regarding distinct signal recovery structures of textual vectors versus novel framework understanding application standards have received crucial recommendations regarding usage clarity improvement. Future study trends identify gaps from methods relevant over newly raised additional results, particularly non-pre-training propagation roles affecting early literature. Promising next-step expansions further comprising attention incorporating attention representation assessments show interrelated elements significant focus enhancing system practical development processes TRGL. Media bias detection, propaganda identification, and fake news analysis are critical topics in natural language processing, computational linguistics, and artificial intelligence. A comprehensive literature review reveals that developing reliable and accurate methods for detecting media bias is crucial, particularly in the context of fake news and political fact-checking. Researchers have proposed novel approaches to media bias detection, including the use of large language models, frame analysis, and semi-automatic bias annotation. High-accuracy models for political bias detection have been developed, along with annotation guidelines for propaganda detection in news items. Surveys and reviews on fake news detection, identification, and mitigation techniques have also been conducted, as well as studies on the spread of true and false news online. The presentation of biased information in news media has been explored, including the coverage of conflicts and uprisings. The complexity and multifaceted nature of media bias detection are evident, highlighting the need for continued research and development. The creation of reliable ground truth datasets for biased language detection and the development of text annotation survey systems are essential. This literature review provides a comprehensive overview of the current state of research in media bias detection, propaganda identification, and fake news analysis, highlighting key challenges, methodologies, and findings in this rapidly evolving field. The shared task provides a collaborative platform for participants to propose guidelines and diverse methods for annotating and analyzing a dataset of social media posts. The dataset consists of 15 batches of 1,000 posts each, with 200 posts from 5 languages: Arabic, English, French, Hebrew, and Hindi, along with their machine-translated versions into Arabic and English. Participants must specify whether they annotated the original language or its machine-translated version. To qualify, each team must provide full annotation guidelines for each subtask and annotate a minimum of 2 batches, totaling 2,000 posts, including a designated interannotator agreement subset of 200 posts, which must be annotated by every annotator on the team. The shared task comprises 2 subtasks, each with 4 evaluation tracks. The first subtask focuses on bias annotation, where participants assign one of 7 possible labels to each post: unbiased, biased against Palestine, biased against Israel, biased against both, biased against others, unclear, or not applicable. The 4 evaluation tracks for this subtask are: overall bias detection per language, bias detection per topic, and interannotator agreement, IAA, quality. The IAA quality track evaluates the agreement between annotators, ensuring consistency in bias annotation. This track is a novel addition to the original call to participate, emphasizing the importance of annotator agreement in bias detection. This section of the research paper outlines the annotation guidelines for identifying and labeling propaganda in news articles. The task's objectives are to accurately identify and categorize propaganda, ensuring consistency among annotators and maintaining quality standards throughout the annotation process. The paper defines 4 categories for annotation: propaganda, not propaganda, unclear, and not applicable. Each category is accompanied by detailed guidelines and examples, including correct applications and common mistakes. For instance, propaganda includes content that uses loaded language, emotive content, and misleading information to sway public opinion. Not propaganda refers to factual information without any apparent bias or manipulation. Unclear refers to content that may be perceived as propaganda but lacks clear evidence, while not applicable is used for content unrelated to the task. The annotation process involves a step-by-step approach, utilizing specific tools and adhering to quality standards. To ensure consistency among annotators, calibration sessions are recommended. Handling ambiguities and difficult cases requires a protocol for seeking clarification when necessary. Training procedures and support resources for annotators emphasize the importance of unbiased annotation practices and proper handling of sensitive data. The paper suggests scheduling guideline reviews for updates based on feedback and new insights, as well as implementing a system for annotator feedback to refine guidelines and processes. This framework provides a comprehensive guide for annotating news articles to identify and label propaganda, emphasizing precision, consistency, and quality in the annotation process. In the ArabicNLP 2024 shared task, participating teams must provide well-documented annotation guidelines that include examples and demonstrate a high level of interannotator agreement, IAA, for at least 200 posts. The competitive Cohen-Kappa score should be 0.6 or higher. The guideline score, used to determine the winners of this track, is calculated as the average of the normalized document score and IAA Kappa score. The document score ranges from 0 to 8, reflecting the number of satisfied document components, while the IAA Kappa score is the average of all pairwise IAA Kappas over team annotators per batch. Teams can also compete in the quantity evaluation track, where the goal is to annotate the largest number of data batches and sequence. The consistency evaluation track assesses the correlation between teams' annotations, with the highest correlation indicating the winner, provided a minimum of 3 teams participate per subtask. All participating teams are invited to submit a 4-page paper describing their efforts, which will be evaluated by multiple reviewers for publication in the ArabicNLP 2024 conference proceedings and indexing by the ACL anthology. The shared task emphasizes collaboration, encouraging participants to share their methodologies, findings, and results openly. Additionally, participants are invited to provide optional demographic details, which will not influence the evaluation of their participation in any way. The annotation interface for the main data subset, illustrated in Figure 1, utilizes a Google Sheet setup to facilitate efficient labeling. This interface is a crucial component of the data curation pipeline, enabling annotators to meticulously label instances with high accuracy. The annotation process is structured around a predefined schema, comprising multiple fields that capture essential attributes of each instance, including entity labels, relationship labels, and relevance scores. Entity labels are categorized into distinct classes, each representing a specific entity type, such as person, organization, or location. Relationship labels denote connections between entities, including hierarchical, associative, or causal relationships. The annotation interface is designed for collaborative and iterative labeling, allowing multiple annotators to work in parallel on unique subsets of instances, thereby reducing overall annotation time. Annotator performance is tracked through interannotator agreement scores, providing insights into the consistency and accuracy of annotations. A comprehensive set of guidelines, informed by domain expertise, outlines the definitions and criteria for assigning entity and relationship labels, and is iteratively refined based on feedback from annotators and the research team. Annotations are reviewed and validated by a senior annotator to ensure labeled data meets the desired quality standards. The annotated data is then integrated into the main data subset, used for model training and evaluation. The annotation interface and guidelines are available as supplementary materials, enabling reproducibility and community engagement. While labor-intensive, the annotation effort yields a valuable resource for training and evaluating models, complemented by quality control measures, including regular audits and annotator feedback mechanisms, to ensure annotations are accurate, consistent, and aligned with research objectives. The annotator demographics are presented in Table 10, showcasing the distribution of annotators across various categories. Native language analysis reveals that Arabic is the most prominent, with 49.3% of annotators, followed by Urdu at 30.9%, and Italian at 4.4%. The remaining languages, including Persian, Dutch, English, German, Hindi, Urdu, Russian, Spanish, and Bengali, comprise smaller percentages. In terms of region of origin, South Asia dominates, with 33.1% of annotators, followed by the Levant at 26.5%, and North Africa at 13.2%. Western Europe, GCC countries, and other regions make up smaller proportions. Education-level analysis shows that the majority of annotators hold a master's degree, with 46.3% of the total, followed by bachelor's degree holders at 36.8%, and doctoral degree holders at 10.3%. A small percentage of annotators have postdoctoral training or prefer not to disclose their education level. The age range of annotators is predominantly 18-24, with 47.8% of the total, followed by 2,534 at 28.7%, and 3,544 at 16.9%. The remaining age ranges, including 4,554, 5,564, and those who prefer not to disclose, make up smaller percentages. Area of expertise is predominantly engineering and technology, with 63.2% of annotators, followed by arts and humanities at 16.2%, social sciences and law at 14.7%, and smaller percentages in education, business and economics, and natural sciences. Notably, the gender distribution shows a significant majority of female annotators, with 77.2% of the total, followed by male annotators at 17.6%, non-binary annotators at 0.7%, and those who prefer not to disclose their gender at 4.4%.